Welcome to another exciting segment of Math with Miss Bennett. Today we're going to be looking at inequalities. Inequalities are like equations, except they have a less than symbol, greater than symbol, less than or equal to symbol, or greater than or equal to symbol. And the good news is equations can be solved. And so can inequalities. A real-life example of an inequality is if you've ever been to a roller coaster place or a theme park and it says you must be at least 60 inches tall to ride, your height must be at the least, so your height must be greater than or equal to 60 inches. In other words, in order to ride, you could be 60 inches exactly, or 60 inches and a half, or maybe 62 inches, or maybe even 70 inches. Now you can see a real-world example of an inequality in use. Sometimes it doesn't matter that the variable is one number. Sometimes it matters that the variable is a set of numbers with a specification. So how do we solve inequalities? Well, we treat them like they're equations. So if this were an equation, x plus 5 is equal to 18, you would solve it by finding the inverse operation of add 5, which is subtract 5. And so to keep it fair, you would do the same thing on both sides of the equation. Now we have x plus 0 is equal to 13, and we know that x is then equal to 13. But wait a second, Miss Bennett, this was never an equation to begin with. You're right, it was always an inequality. So instead of x is equal to 13, we're going to copy that inequality symbol, x is greater than 13. If you want to check it, pick a number that's greater than 13. Let's say we'll go to 14. 14 plus 5 is 19. 19 is greater than 18, so it works. Now, a common mistake is to skip to the next number. There are numbers that are greater than 13 that are not 14. For instance, x could be 13.5, so it's important not to skip to the next number. Our next problem is x minus 2.2 is less than or equal to 1.5. So just like before, we're going to treat it like it's an equation instead. X minus 2.2 is equal to 1.5. And now we're going to solve it. We need to do the inverse operation of minus 2.2 so that we can isolate the variable or get it alone. We're going to do addition of 2.2 on both sides to keep the equation fair and balanced. Now we have x minus 2.2 plus 2.2, and if we add or subtract the same number, add and subtract the same number, we get 0. And then here we have 3.7. Now we know that x plus 0 is just x, and we get 3.7. Of course, just like before, this never was an equation to begin with. So x isn't equal to 3.7. It's actually less than or equal to 3.7. Now checking this one is a little bit different, because if we were to check it, we have to include 3.7 in what we check. 3.7 minus 2.2 is equal to 1.5. So that works. Now we need to pick a number that's less than 3.7. I'm going to go with 3.3. 3.3 minus 2.2 is less than 1.5 because 3.3 minus 2.2 is 1.1. So we can see that it works. Again, you can't skip to another number. You have to leave it as is. Next piece. 5x is greater than or equal to 40. This time we're going to treat it like an equation without writing an equal sign. So if this were an equal sign here, what would we do? We would try to undo the times 5 on the x. The inverse of times 5 is divide by 5. And remember, in algebra, we use a fraction bar instead of this division symbol. So no division symbols in algebra, only fraction bars. Now, x times 5 divided by 5 is 1x, which is greater than or equal to 40 divided by 5 is 8. And 1 times x is just x. And so now we know that x has to be a number that is 8 or greater than 8. So let's check it. If I put in my value, see, 5 times 8. 5 times 8 is equal to 40, so it works. What about 5 times 8.5? 5 times 8.5 is 42.5, and 42.5 is is greater than 40. So you can see it works. This is how you solve inequalities. You treat them like they're equations. But inequalities have one more piece. Inequalities come with graphing. So let's talk about how to graph some inequalities. This is actually the easiest part. If x is greater than 2, we're going to start with a dot on 2. We do not shade this dot because 2 is not greater than 2. The answer for x cannot be 2, so we're going to leave it unshaded. Then we have to shade where all the numbers are greater than 2. That would be numbers like 3, 4, and 5. And we're going to draw an arrow because this set of values keeps going past the graph. If x is greater than or equal to 2, the graph changes just slightly. Now that x can be 2, we're going to shade in the dot. This tells us that the value can be that. And because we want the numbers greater than 2, like 3, 4, and 5, we're going to shade to the right. If x is less than or equal to 2, we're going to start with our dot, and then we're going to shade it because x can be equal to 2. And then we're going to shade where the numbers are less than 2. Numbers like 1, 0, and every negative number. And we're going to draw an arrow because numbers continue forever, and any number smaller than 2 or equal to 2 counts as an answer. And then finally, x is less than 2. Do not shade the dot. It can't be 2. 2 is not less than 2. And shade to the left because x can be any number less than 2, like 1 or 0 or negative 12, for instance. And there you have it. Inequalities graphed. Now we're going to look at a real-world scenario, sort of like the word problems on your worksheet. Bobby has $45 in birthday money to buy new jeans. He needs 3 pairs. If we assume each pair costs the same amount, write an inequality to represent the possible cost of jeans he can buy. Well, we know if this weren't an inequality problem, we would have to do 45 divided by 3 to figure out the cost of the jeans. 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 is 1, and carry down the 5. 3 goes into 15 5 times. 3 times 5 is 15. 15 minus 15 is 0, and we're done. The maximum cost is $15. Unfortunately, we want this written as an inequality, so we're going to need to put that in math language. So the cost of jeans, and I'm going to go with C for cost. The cost has to be equal to, because we could buy $15 of jeans. $15 times 3 is exactly 45. Equal to or less than $15. Because imagine if we were to buy jeans that cost just $15.01. $15.01 times 3 would give us $45.03, which would be 3 cents too many. So the jeans cost must be less than $15. And there's your inequality. If you wanted to graph the inequality, you would need a number line with 15, 16, maybe 14. And we can buy a $15 pair of jeans or something less. Shade to the left, like $14 would be appropriate. He'd have money left over, he could buy it. And then shade it in. And there you have it. Inequalities. So a quick recap of inequalities shows that inequalities can still be solved. They just come with a range of answers instead of one single answer like an equation. We solve them by treating them like equations and then going back and remembering to include the inequality symbol. To graph inequalities, we need to pay attention to two things. Is it a regular inequality symbol, or is it an inequality that is or equal to? That determines whether or not we shade the dot. If it's or equal to, shade the dot. For the others, don't shade the dot. And then you can shade in the direction where the answers are. So ask yourself, what could X be? And then shade in that direction. Finally, when looking at word problems with inequalities, you want to pay attention to the real-world math, maybe write a statement, and then turn that statement into an inequality. Don't forget to check your work to make sure you've answered it correctly, and if it asks to draw, careful to draw it right. And you have joined another exciting segment of Math with Miss Bennett. I'll see you next time.